Good evening, children. Welcome to Akshara IIT classes. This is Srinivas, your maths faculty. Welcome to today's class. Right. So we are in just transformation of right. Yeah, we have discussed some of the important topics previous classes like congruent rules, Fermat rule, Wilson rule, right? Yeah, based on that we are doing some exercise problems also. Let us see this. So I think we have already completed 7 problems, so we need to do 8th problem. Now a plus 1, yeah, a plus 1 equals to b, then what is the congruent rule is suitable to the given equation? A plus 1 is equals to b. Right. Let us go through the options. Okay, na? But what is the congruent rule? If A is congruent to B modulo n, A is congruent to B modulo n, then A minus B is divided by n. Am I right? A minus B is divided by n. Now see here, A plus 1 is equals to B, it seems. A plus 1 is equals to B. That is nothing but A plus 1 is divided by B or not? A plus 1 is divided by B or not? Obviously, because A plus 1 value is already B. That means in the place of A plus B, we can write B. Am I right? A plus 1 is divided by B. That means we can write A is congruent to minus 1 modulo B, where A minus 1 and B, these three can be integers. Now according to this, A minus B is divided by n. Am I right? A minus B is divided by n. That means here also A minus, in the place of B we have minus 1 is divided by B. That means A minus of minus become plus 1. A plus 1 is divided by B. This is only we have taken, right? See? So from the condition A plus 1 equals to B, that means we have to identify that this A plus 1 should be divisible by B. Am I right? Yeah, that's why I have written that A is congruent to minus 1 modulo B. That means when you bring minus 1 this side, it will be plus 1. It will be plus 1. See? Like A minus B divided by n condition. A minus B divided by n condition. So same way here also, this is considering as A, minus 1 is considering as B, and this modulo B can be considering as n. A congruent to B modulo n is possible when A minus B is divided by n. Same condition, A minus B value here minus 1. Minus or minus become plus. So A plus 1 is divided by B. So option 1 is exactly suitable to the given one. Okay, na? Right. Now let us see that option 4. Option 4 is also looking like A is congruent to minus 1 modulo A. But minus 1 modulo A is not suitable because here modulo B should be to satisfy the congruence rules. Okay, na? Right. Let us go to the next problem. Right. Units place of 9 power 2012 is dash. So while we are discussing about 9 powers 2, 3, 7, 8. These numbers are following. That means these numbers, that 2 power 1, 2 power 2, 2 power 3, if you check like that, 2, 3, 7, 8 are repeating after 4th term. That means the sequence is repeating for every 4 terms. For 2, 3, 7, 8. 4 and 9 is repeating for every 2 terms. That means when 4 power even number when 4 power odd number, it is a sequence, same sequence will be repeated. Let us see, that means 9 power 1 value how much? What is the value of 9 power 1? 9 power 1 means 9. 9 square? 9 square means 81. 9 nines are 81. So it is ending with the unit digit 1. 9 cube. 9 cube value 729. 9 cube value 729. That means unit digit is 9. See, only 2 terms it is following. Again, next series continues. That means sequence is continuous, like 9 1 9 1 9 1, like that. That means 9 power odd number will give you the unit digit 9. 9 power even number will give you the unit digit is 1. What is that? 9 power odd number gives you the gives the unit digit is 9. 9 power even number gives the unit digit is 1. Now let us see 9 to the power of 2012. 2012 is even number or odd number? Very good. It is an even number. So its unit digit will be 1. Okay, na? Same way, what is the 4 power even number and 4 power odd number? Yeah, 4 power 1. Let us see, 4 power 1 is 4. 4 square, 4 fours are 16. So unit digit is 6. 4 cube means 4 into 4 into 4. 64. Again unit digit is 4. That means after 2 terms, again the sequence is repeating. Here 4 power odd number gives you the unit digit 4 and 4 power even number gives you the unit digit is 6. Okay, na? Yeah. So simply the answer for 9 power 2012 is 1. 9 power 2012 is 1. Now can you guess me the answer for this? 9 power 5025. What is the answer? That means what is the unit digit of 9 power 5025? Yeah, very good. Because 5 power 25 is an odd number. Odd number is always ends with the unit digit is 9. Very good, nice. Yeah, let us go to the next problem. Right, the integers less than 10. Integers less than 10 which is co-prime to 3. Now let us check. Integers less than 10 means there are infinite number of integers less than 10, because we can take 10 to 0, minus 1, minus 2, minus 3. Negative integers also we have, but while we checking for the co-primes, we need to use only positive numbers. We need to use only positive numbers. Now the numbers which are less than 10, that means up to 9, which are co-prime to 3. What are co-primes? Co-prime or relatively prime numbers, both are same. We have discussed in so many situations, right, in real classes. Right, co-primes or relatively prime numbers are nothing but two numbers does not have any common factors. That means there must be only one is the common factor. That means no other common factors except one. That type of numbers are called co-primes or relatively prime numbers. What are they? Co-primes or relatively prime numbers. That means there is no common factor except one. Am I right? Yeah, there is no common factor except one. Such type of numbers are called co-primes or relatively prime numbers. Now let us see. We have to identify the co-primes 2, 3. Now let us see with 1. 1 and 3 are co-primes or not? Yes, 1 and 3 are co-primes because there is no other factor between 1 and 3. And coming to 2, Yeah, 2 and 3 also co-primes. Because 2 is a prime number, it is having the factors 1 and itself. 3 is also a prime number, having a factor 1 and itself. Only 1 is the common factor. So 2 and 3 also co-primes. Check with 3 itself. 3 itself is are not a co-primes because there are two common factors 1 and itself. Am I right? 3 also the common factor between 3 and 3. So 3 and 3 we are not considering as a co-primes. Next 4 and 3. 4 and 3 also co-prime numbers because there is no common factor except 1. 5 is a prime number. Yes, 5 and 3 we can take. Both are having common factor only 1. Nothing else. Next 6. 6 will come in 3 table. So we are not considering 6. Now 7. 7 comma 3. These two also a pair of numbers which are having only 1 is a common factor. So 7 comma 3 also a co-primes. Now 8. What about 8? Yes. 3 table 8 won't come. So 3 and 8 having only 1 is the common factor. Let us check. What are the factors of 8? 1 8s, 2 4s. That's it. So 1, 2, 4, 8. 3 factors means 1 and itself because 3 is a prime number. Because here while you are observing here 1 is a only common factor between 3 and 8. So these two also a co-primes. Compared to 9. 9 will come in 3 table. That means we can find one more extra factor with 1. So 9 we are not writing and we are not considering 10 even because here clearly even integer less than 10. Less than or equals to 10 means we can write. Less than or equals to 10 means we can consider 3, 10 are co-primes because here clearly given that less than 10 only. So we have to take up to 9. We have to check up to 9. So how many are there? 6. There are 6 co-primes. Your option is 3. Right. Now I think you can understand about what are co-primes or relatively prime numbers. Yeah. LCM of the numbers 12. 3 numbers are given. We don't know the 3 numbers, but their ratio we know. The numbers are in the ratio 1:2, 2:3. What is the ratio? 1:2, 2:3. The ratio of 3 numbers is 1:2, 2:3 and the LCM of 3 numbers is 12. LCM is 12. Now we need to find the numbers. We need to find the numbers. So before that, let us add these 3 numbers. Because whether it is given in 1:2, 2:3, that can come in any other table. That means there is a common factor between 1, 2, 3. That common factor can be 10, 100, 200, 300, whatever it can be. It will have different numbers. Like it can have 10, 20, 30. The numbers can have the numbers can be 10, 20, 30 because these 3 also following the same ratio 1:2, 2:3. Okay, na? Before that, let me check their sum. I am just adding the sum 1 plus 2 plus 3. 1 plus 2 plus 3 is nothing but 6. 1 plus 2 plus 3 is nothing but 6. But what is the LCM here? 12. LCM is 12. Now, with 6, in 6 table 12 how many times? 6 table 12 how many times? 2 times. Am I right? So, 12 can be written as 2 into 6. So, 6 table 12, 2 times. Now, here we can identify that 2 is a common factor. We should identify that 2 is a common factor. So, let us multiply each number with 2. 1 2s are 2. 2 2s are 4, 3 2s are 6. So 2, 4, 6 are the required numbers which gives the LCM 12 and follows the ratio 1:2:3. Okay, na? Just I am taking the sum of numbers. and I checked how many times it will come in LCM. So our required answer is 2, 4, 6, option 4. Yeah, please note it. Very easy, we can do like this. Yeah, let us see the next question. Right, 12th one. If P is a prime number, and A is any number such that A comma P is equals to 1. What is the meaning of this? A comma P equals to 1. That means if two numbers are given like this in the brackets, that is equals to 1 means HCF of A and P is 1. That means it is indicating, if it is given A comma P equals to 1 in a bracket like this, A comma P, you have to identify that the HCF of the numbers A and P, HCF of the numbers A and P is 1. HCF means what? Highest common factor. Here 1 only the highest common factor, then you should identify that A comma P are, only 1 is the common factor here. Yes, co-primes. A comma P are co-primes or relatively prime numbers. Okay, na? For example, in the bracket it is given like 2 comma 3. So we can say that HCF of 2 comma 3, that is equals to 1, because 2 comma 3, both 2 and 3 are both are co-primes. Okay, na? Right. So if P is a prime number, A is any number such that A comma P equals to 1, this condition we have identified in our previous classes, that is Fermat's theorem. What is that? Yeah, Fermat's theorem. Okay, what is the Fermat's theorem? If A power P minus 1 is congruent to 1 mod P, where P is a prime number, A is any number, we can write Fermat's theorem like this: A power P minus 1 is congruent to 1 modulo P, or A power P is congruent to A modulo P. Okay, na? Right. So our required answer is this or this. Any one of the option you can choose from your given options. Okay, no? Right. Let us see the next problem. Yeah. LCM of two numbers is given. What is LCM of two numbers? 105. Yes. LCM is 105. HCF of two numbers. HCF also given. HCF of the same two numbers is 1. Difference of numbers is 8. Difference of numbers is 8. Then the sum of numbers is, we need to find the sum of numbers. Okay, let us see that condition or relation between LCM and HCF. What is the relation we have discussed in our previous classes? Yes, product of two numbers is equals to product of two numbers equals to product of LCM and HCF. Product of LCM and HCF. Right, let us see this. LCM value is already given 105, and HCF of two numbers is 1. Now just tell me that if two numbers having HCF is 1, we can call the two numbers as co-primes or relatively prime numbers. Co-primes or relatively prime numbers. Okay, but we don't know the two numbers, but here we have one condition is given, that means one clue is given, difference of two numbers is x. Difference of two numbers is x. For example, one of the number is x. One of the number is x, then the other number we can take it as x plus 8 or x minus 8. Anything. Difference between these two also 8. Difference between these two also 8. Okay, no? Now to identify that, let me find out the 105 into 1 is 105. Let me find out the prime factors of 105. Prime factors of 105. Let us see. 5 table. 5 2s 10. 5 1s are 5. Now 3 tables 7 times. And 7 table 1 time. Because 105 into 1 value is 105 only total. Product of LCM and HCF is nothing but product of two numbers. That means when you multiply these two, LCM and HCF, we can identify that product. Right. So this can be written as 5 into 3 into 7. Now let us see this. 5 3 is how much? 15. 7, leave like that only. What is the difference between 15 and 7? 8. Am I right? Difference between 15 and 7 is 8. So 15 and 7 are our required numbers. 15 and 7 are required numbers. Because 15 7s are 105. 15 comma 7 are required two numbers. Their difference is 1. Sorry, difference is 8. Now what is the question is asked for us? Sum of numbers. They are asking about sum of numbers. That means 15 plus 7 is 22. 15 plus 7 is 22. So our answer is second one. Yeah, please check it. Here we just guessing the numbers by identifying the prime factors of 105. Not guessing exactly correct only because 15 and 7 having a difference 8. We can do in another way also, like taking unknown value as x, another number is x plus 8. The product of two numbers x into x plus 8, like x into x plus 8 is equals to 105. Again, if you simplify this, it will be in the form of quadratic equation. Again, we need to solve the answer. That means you need to identify the x value in that by solving quadratic equation by prime factorization method, or like factorization method, splitting the middle term. So that is a full process will be there. So but here we can use the concept of relation between LCM and HCF concept. Okay, na? Right. Okay. So let us go to the next problem. The number of integers from 1 to 2001 that are relatively prime to 2002. Relatively prime to 2002. That means we need to check the integers from 1 to 2000. Like previous problem, check here. What is the previous problem? We did like this. The integers less than 10. That means 1 to 10 we are checking. 1, 2, 3, 4. All numbers we have written, and each and every number we have written like this. Am I right? But here question is given 1 to 2001. That means 2000 numbers we should write. Is it possible to write 2000 numbers and checking one by one with 2002? It is possible, but will take more time. So, but here we have one of the property is there in your material, that is nothing but Euler's quotient theorem. That is nothing but if a composite number n, the composite number n is in the form of product of prime numbers like P1 or not P1, we just take it as P, or P1 also doesn't matter. Yeah, P power A into Q power B into R power C and so on like this, where PQ are set of prime numbers. Simply like composite number can be expressing as product of prime numbers. We used to learn until then like P1 power n1 into P2 power n2 into P3 power n3 like. Okay, I'll say in this model only. If a composite number expressing in a way, then number of integers that are relatively prime to the given number, are relatively prime to such number is the composite number n into 1 minus 1 by P1 into 1 minus 1 by P2 into 1 minus 1 by P3 and so on like this. This is the required format. Here we should take that n is a composite number. That composite number is 2002. Composite number is 2002. That 2002 we have to express like this, where P1, P2, P3 are prime numbers. Okay na? Euler's quotient theorem. So let us identify the composite number 2002 in its prime factor form. Okay, two table let us see. 2 ones, 2 into 1001, 1001 times. 2 into 1001 is 2002. Now 1001, I think it is coming in 7 table. Yeah, 7 ones are 7. We got 3 remainder 30. 7 fours, 28, 2 remainder 21. Yes, 7 threes. So 1001 is not a prime number. 1001 will be divisible by 7 table. Now 143 will come in 11 table. 11 13s, 13 ones. Okay, na? Now 2002 can be expressed as 2 power 1 into 7 power 1 into 11 power 1 into 13 power 1. Okay, na? So we are not considering any exponents here. We are just checking the prime numbers which are present in the factorization of 2002. Okay, na? Yeah, let us see. Let us substitute in the formula. N is nothing but composite number itself, 2002 into 1 minus 1 by first prime number is 2. Next 1 minus 1 by second prime number is 7. Next 1 minus third prime number is 11. 1 by 11 and fourth prime number 13. 1 minus 1 by 13. Let us simplify. I am going to write here. That is equals to 2002 into 1 minus half. 1 minus half is nothing but half. That means we have to remove half from 1. Still half will be remains. Now see second one. 1 minus 1 by 2. We no need to do the LCM and all. It is looking like a mixed fraction now. You can remember like this. 7 ones are 7. 7 minus 1, 6. So this is 6 by 7. And 1 minus 1 by 11. This is also same like that. 11 ones are 11. 11 minus 1, 10. 10 by 11. So same like this one. 12 by 13. But you know already 2002 is expressing as 2 power 1, 2 into 11 into 7 into 13 into see that remaining part. That means I am expressing 2002 in prime factor form. I have written in prime factor form. Now let us see the remaining. I am writing the numerators here. 1 no need to write. 6 into 10 into 12 by denominators. 2 into 7 into 11 into 13. So numerator, denominator cancel, only remains 6 into 10 into 12. 6 12s are 72. 72 into 10, 720. Yeah. Okay, na? So just listen this. Only your totient number. Totient theorem is nothing but a composite number is expressing as product of prime numbers. That number of integers which are relatively prime numbers, relatively primes to the given composite number is nothing but formula is n into 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3 and so on like that, where p1, p2, p3 are prime numbers. Okay, na? This is very, very important. Please note it, children. Euler theorem. Next, let us go to the next problem. Yeah. So I left the 15th problem because it is related to somewhat different formulas and all. We need to discuss in separate class. Okay, na? There are nearly 4 or 5 formulas there, which are in the form of a power n minus b power n, which is divisible by a minus b or a plus b. That means it is nothing but algebraic divisibility rules. That means if the numbers are in the form of algebraic expressions, so how it is divides. So that will take nearly one class completely. That's why I am going to explain the 15th problem when the concept is discussed. Okay, na? Right. The number, this is the given number, is divisible by 8, it seems. Is divisible by 8. Then the largest digit that can be replaced x. Largest digit that can be replaced x. So before going to this problem, once we have to recollect the divisibility rule for 8. What is the divisibility rule for 8? Last 3 digits are zeros or multiples of 8. Last 3 digits are zeros or multiples of 8. Let us see this. What are the last 3 digits here? 5, x and 2. 5x and 2. There is no presence of zeros. So we can neglect zeros. Remaining multiples of 8 we should take. Let us take in the place of x we can take 0 to 9 numbers. If you take 10, it is 2-digit number, is not possible. So 0 to 9 we can use here. What is the highest number which is exactly divisible by 8 table? Now let us see that in the place of x I am substituting 0. 502. 502 is exactly divisible by 8, because is it multiple of 8? No. 502 is not a multiple of 8. Check. 8 6 are 48. 8 2 16. Yeah, 6 remainder. It is not exactly divisible by 2. That means a cannot be 0. Sorry, x cannot be 0. Let us check 1. Yeah, 512 is nothing but 8 cube. 8 into 8 into 8. 8 8s are 64. 64 8s are 512. So x value can be 1. I am writing x value can be 1. X value cannot be 0. Okay, na? Now let us check for 2. 522. Same process here. 522. Yeah, not coming. Let us check for 532. Okay, na? So 532 will be divisible by 8. 8 6 are 48. 52 here. No, it is also not coming. Now let us check for 540. Not coming. 552. 542 also not coming. So 4 also not getting. Okay, na? 552. Let us check 552. Yeah, 8 table. 8 6 are 48. 72. Am I right? 8 9 72. Yes, 552 can be divisible. So 5 is a chance. Next, 6. 6 won't come definitely because 82 will come. That means remainder 82 will come. Okay, na? 7. 8 7s are 56, not coming. 12. 12 won't come. 8. 22 won't come. 9. Yes, 592. 8 table, 8 6 are, sorry, 8 7s are 56. 32 exactly divides. So 532, that means 592, that means 9. So among them 9 is the highest number. You are checking from 0 to 9, that's why it is getting more time. If you check from 9 to 0, it will get easily, right? So what is the largest number here? 9. Because the last 3 digits must be divisible by 8. Okay, na? Yeah, that's it for today, children. Thank you, one and all. Have a nice day.